Imagine for a second that you're uh, sitting right at the main control board of the universe.
Well, that's a lot of pressure.
Right. But just picture it. Right in front of you, there's this massive panel of dials. And, you have a dial for the speed of light. You've got another one for the gravitational constant. You have another one for the mass of an electron.
Well, heavy hitters.
Exactly. And if you reach out and just, bump that gravity dial by even 1%, well, stars never ignite. Our entire existence relies on these perfectly tuned, highly specific numbers.
It really does. It's an incredibly delicate balance.
But, what if those numbers aren't random at all? What if they aren't just arbitrary settings on a cosmic dashboard?
Well, that question has literally kept physicists awake at night for a century. I mean, we're taught to just accept these fundamental physical constants.
Right. They're just baked into the universe.
Exactly. We measure them in a lab, we write them down in our textbooks, and we just treat them as the brute facts of reality. The universe just is the way it is. But the research we're looking at today completely upends that assumption.
It really does. We are doing a deep dive into a truly mind-bending paper by Chiang-Kai Chen, and it's titled Dual Spectral Alignment and the Emergent Approximations of Physical Constants.
It's a title that definitely promises a lot.
It does, and the mission of this deep dive is to explore Chen's radical proposal that these constants aren't just isolated random numbers. They might actually be the visible evidence of a hidden underlying mathematical code.
Yeah, the framework Chen proposes suggests that physical constants are emergent. Like, they're the offspring of two entirely independent mathematical systems that are interacting with each other.
Two systems interacting.
Right. And to really understand how this works, we need to break down the two ingredients he's bringing together here.
Okay, let's unpack this.
Yeah.
Because, to grasp how the speed of light or the mass of an electron might be emergent, we really have to look at these two separate systems. The paper refers to them as spectra.
Yeah, think of a spectrum here as an engine that generates a specific sequence of numbers.
Okay.
The first engine is what Chen calls the phi spectrum, and this represents the purely mathematical domain. It's built entirely around the golden ratio, which, as we know, is represented by the Greek letter phi.
Golden ratio. I think most people have probably heard of that in maybe an art class or a biology class.
Oh, absolutely.
It's that mathematical proportion we see everywhere in nature, right?
Yeah.
Like the spirals of pine cones, the arrangement of seeds in a sunflower.
It's the shape of spiral galaxies.
Yeah, it's everywhere.
It is arguably the most fundamental structural ratio in all of mathematics. Now, to generate this phi spectrum, Chen uses what's called a logarithmic exponential scaling system.
Okay, let me stop you there, because my eyes instantly glaze over a bit when I hear logarithmic exponential scaling system.
Mm-hmm.
Can we ground that in something every day?
Sure. Well, consider how the Richter scale works for measuring earthquakes.
Okay, yeah. Like a magnitude 5 versus a magnitude 6.
Exactly. A magnitude 6 earthquake isn't just one tiny tick stronger than a magnitude 5. It's actually 10 times stronger in terms of wave amplitude.
Wow, okay.
And it releases over 30 times more energy. The steps between the numbers they represent massive compounding leaps. And Chen is basically using a similar concept here. The system creates steps that scale exponentially.
So instead of a normal ruler where every single inch is the exact same, the gaps between the tick marks get larger and larger based on a specific multiplier.
You've captured the core idea perfectly, and the multiplier, the fundamental generator for this entire mathematical domain, is the square root of the golden ratio.
The square root of phi.
Right. Now, there is also a scaling factor involved. It's essentially a mathematical trick to shift the decimal point around so we can easily compare these generated numbers to the known constants. But the real heart of the engine is the golden ratio.
And this engine actually produces real mathematical constants, like the numbers check out.
It is incredibly prolific. I mean, in previous work, Chen actually demonstrated that this specific phi spectrum generates values that match over 100 known mathematical constants.
Over 100?
Yeah, with an accuracy of over 98%.
That's wild.
It really is. We're talking about things like pi, Euler's number, various constants that show up in geometry and calculus. They all naturally fall out of this one scaling system based on the golden ratio.
That alone is just staggering to think about. A single, relatively simple structural rule spitting out 100 foundational numbers of mathematics.
Right.
But as you mentioned earlier, that's only the first ingredient. That handles the math side. But math is purely theoretical until we introduce the physical stuff we can actually, touch and measure.
Which brings us directly to the second system in Chen's framework, the ternary spectrum.
Ternary meaning 3.
Exactly. If the golden ratio rules the mathematical domain, the physical domain is governed by the number 3, base 3.
The number 3. That feels almost, I don't know, almost too simple.
Well, the simplicity is kind of what makes it so elegant. The mathematical structure is identical to the phi spectrum, but the fundamental generator is swapped out.
Okay, so what runs the engine now?
Instead of the square root of the golden ratio, the engine runs on the square root of 3. And just as the phi spectrum successfully generated mathematical constants, previous research showed that this ternary spectrum generates values that map astonishingly well onto the physical world.
Okay, how well are we talking here? What kind of physical things?
It matches the masses of all 15 fundamental particles in the standard model of physics.
Oh, wait. All of them.
All 15.
I want to make sure we don't just gloss over that because that's huge. For you listening, the standard model is essentially the periodic table for the very fabric of reality, right?
That's a great way to put it, yeah.
We're talking about quarks, which make up our protons and neutrons. We're talking about leptons, like the electron, and the bosons, right?
Yeah.
Particles that carry the fundamental forces of nature.
Every single foundational Lego brick of the universe.
Wow.
And, for decades, physics has basically treated the masses of these 15 particles as completely random weights.
Like, there's no reason they weigh what they weigh.
Right. There was no obvious reason why an up quark weighs what it does compared to, say, an electron. But Chen's work suggests they aren't random at all. Their masses can be mapped to an exponentially scaling sequence based purely on the number 3.
Okay, so picture this in your head. You're holding 2 completely independent measuring tapes.
Okay, I like this.
One measuring tape has tick marks that are spaced out using that expanding logarithmic scale based on the golden ratio. That's our math tape measure.
Right.
And the other tape measure has tick marks spaced out using the number 3. So that's our physics tape measure.
It's a great visualization because both of those tape measures, they stretch out infinitely. They generate thousands upon thousands of possible numbers or, tick marks.
But here is the big unresolved mystery that Chen is trying to crack. Out of all those thousands of marks on the physics tape measure, why do only a handful of them correspond to real, actual physical constants in our universe?
Exactly.
Like, why does the universe choose to build an electron at one specific tick mark while leaving the next 100 tick marks completely empty?
That is the pivotal question. Because if the ternary spectrum offers all these possible slots for physical reality, what's the selection mechanism? Why does reality manifest in some spots and not others?
Here's where it gets really interesting, because Chen's solution is to take those 2 tape measures we just talked about and lay them directly on top of each other.
Yeah, he introduces a concept called the discrepancy function, which he represents with the Greek letter delta. And delta is just the classic mathematical symbol for change or difference.
So we're essentially looking for the difference between the 2 tape measures.
Simply put, yeah. The delta function calculates the absolute mathematical distance between a value generated by the math spectrum and a value generated by the physics spectrum. It measures the mismatch.
Okay, got it.
When you lay those 2 tape measures side by side, delta is just the physical space between a tick mark on the golden ratio tape and a tick mark on the base 3 tape.
I think I see where this is going. So we're basically sliding these 2 completely independent patterns over each other, and we're looking for the exact spots where the tick marks accidentally sync up or overlap.
What's fascinating here is that the author's central idea relies entirely on those moments of alignment. This is what Chen calls the emergent approximation principle.
Emergent approximation.
Right. The theory proposes that physical constants are not just reading off the base 3 physics tape measure in isolation. Instead, the fundamental constants we actually observe in nature preferentially occur exactly where that discrepancy, that delta, is minimal.
They happen right in the spots where the 2 tape measures agree.
They emerge from the harmony. They are born from the close alignment of these 2 completely independent recursive systems.
That's incredible.
You can think of it like the universe acts a bit like a tuning fork. When the mathematical scaling structure and the physical scaling structure hit the exact same value at the exact same time, that specific value stabilizes, it resonates, and it becomes physically realized in our universe.
Wow, okay. Picture taking 2 normal window screens, just standard mesh screens, and laying them over each other.
Oh, sure.
Individually, they're just boring uniform grids, nothing special. But when you slide them over each other, suddenly these huge, complex, swirling geometric patterns appear.
Yes. Moire patterns.
Exactly, moire
A
patterns.
moire pattern is actually the perfect analogy for emergence because the swirling pattern isn't actually printed on either of the two window screens.
Right, it's just empty space.
It only exists as a property of their relationship. It emerges from the intersection of the two grids. And Chen is basically arguing that the fundamental constants of our universe, like the speed of light, gravity, the mass of a quark, are the moire patterns of reality.
Wow.
They only exist because the math grid and the physics grid align.
It is such a beautiful, deeply poetic way to view the universe. But, poetry doesn't get you very far in a physics lab.
No, it doesn't.
We need to look at the data. Does this actually map onto the messy, complicated reality of our world?
And to answer that, we have to look really closely at the empirical evidence Chen provides in the paper.
Right. I actually have Table 1 from the source text pulled up right now. It's titled The Real World Constant Grid. But just looking at all these numbers, it's a bit overwhelming.
There's a lot to process.
Let's break this down for everyone. Let's look at the column where the delta discrepancy is exactly 0.00, meaning the mathematical golden ratio tape and the physical base 3 tape landed on the exact same spot with zero mismatch. What constants are sitting in that bucket?
Well, the values we find at absolute perfect alignment are incredibly foundational. We find the elementary charge, which measures out to 1.6022 times 1019 coulombs. We find the mass of the muon particle sitting at 1.0566 times 180 weight electron volts over c squared.
Okay.
And we also find the Compton wavelength right at 2.4263 times 1012 meters.
Just to give some context for you listening, those aren't just random trivia numbers. The elementary charge is the foundational unit of electricity in the universe. It literally dictates how atoms bond together.
Right.
And a Compton wavelength.
Yeah.
That sets the fundamental limitation on measuring the position of a particle. It's the bedrock of quantum mechanics. You're saying they exist perfectly at delta zero.
Zero mathematical discrepancy, complete harmony between phi and base 3.
That is just, wow. Okay, what happens if we move just a tiny bit off perfect center? Say we look at a delta of just 0.01, like a microscopic fraction of a difference.
Well, at a discrepancy of 0.01, we find the absolute heavyweight champion of physical constants. The speed of light?
The speed of light.
2.9979 times 108 meters per second.
The cosmic speed limit. The constant that literally ties space and time together in Einstein's relativity. It just falls out of the equation at 0.01.
It does, and sitting directly alongside it, also at a 0.01 discrepancy, is the mass of the electron, measuring 5.1100 times 105.5 electron volts over c squared.
Alongside it. That's wild.
And remember, the electron is the particle responsible for all chemistry, all electronics, basically the entire structure of the physical world we interact with daily.
This is starting to give me goosebumps, honestly. But let's keep stepping out. What about a delta of 0.02?
Moving slightly further out to 0.02, we hit another foundational pillar, the gravitational constant.
Okay, 6.6743 times 1011.
Exactly, the force that holds planets in orbit, creates galaxies, and, collapses dying stars into black holes. We also find the up quark sitting in that exact same 0.02 zone, which is one of the primary building blocks of the matter inside our own bodies.
I have to stop you there, because my skeptical alarm bells are ringing loudly right now.
Fair enough.
Let me play devil's advocate for a second. This sounds amazing, but isn't this potentially just the Texas sharpshooter fallacy?
Ah, the Texas sharpshooter. That being the concept where a person fires a bunch of random bullets into the side of a barn and then walks up and paints a bullseye around the tightest cluster of bullet holes just to make it look like they're a master marksman.
Exactly. Sorry, that just hits at the core of my concern. We have these two tape measures, right? They stretch on to infinity. They generate thousands and thousands of numbers. Aren't they bound to cross paths eventually just by pure random chance?
That's a very logical question.
Like, if you have enough generated numbers and you compare them to the hundreds of random constants we've measured in physics, of course you will find some matches. Why shouldn't I just write this off as a massive mathematical coincidence?
And that is the most crucial, critical question to ask regarding any theory of numerology and physics. But the author actually addresses it directly. And the reason this avoids the Texas sharpshooter fallacy is because of the empty space.
The empty space? What do you mean by that?
Well, if the matches were purely random chance, we would expect to see physical constants scattered somewhat evenly across the entire landscape of discrepancies.
Like a normal distribution?
Yeah. We would find just as many physical constants sitting at a delta of 0.5 or a delta of 0.8 as we do near zero.
But we don't.
We really don't. The data shows a highly structured clustering. If you look at regions in the dual spectral landscape where the delta value is larger, meaning the discrepancy between the math tape and the physics tape is significantly positive or negative, while the correspondence with known physical constants becomes incredibly weak or entirely absent.
So there are literally no fundamental physical laws hiding out in the high discrepancy zones.
None. The high discrepancy zones are barren, and this transforms the idea from a neat coincidence into a true selection principle.
A selection principle.
It dictates that low discrepancy spectral alignments are the strict prerequisite for a physical constant to be realized in nature. If the mathematical system and the physical system don't agree, the universe simply refuses to build a constant there.
So the universe only builds where the foundation is supported by both math and physics.
Exactly.
It really comes back to that tuning fork analogy you made earlier. If the frequencies are wildly different, they just cancel each other out. Reality doesn't resonate. It only hums when the two frequencies are near perfect matches.
It's a mechanism of profound stability. The physical constants are stable precisely because they're reinforced by these dual recursive structures.
So what does this all mean for the future of science? We have these two mathematical patterns. We measure their overlap with this delta discrepancy function, and we find that our physical reality is just hiding in the zeros. Does this actually change how physicists do their jobs tomorrow?
If we connect this to the bigger picture, it represents a massive paradigm shift in how we approach theoretical physics. Just think about the last century of research. Physics has spent an enormous amount of time, energy, and frankly, billions of dollars trying to derive these constants from first principles.
Right, like trying to find the elusive theory of everything, the one grand unifying equation that mathematically proves exactly why the electron absolutely must have the exact mass that it does.
Exactly. They want an equation that spits out the number perfectly. But Chen's framework shifts the focus entirely. It suggests we shouldn't be looking at these numerical values in isolation at all. We no longer have to view the speed of light or the mass of a quark as an arbitrary standalone number that a single equation must dictate.
Because they aren't standalone numbers at all. They're relationships.
They are stable emergent values. They only arise because two entirely independent scaling structures happen to intersect at that specific scale. One mathematical, based on the golden ratio, one physical, based on the number 3. This framework provides a consistent organizing structure for the numerical regularities of our entire universe.
Now, to be fair to the rigorous scientific process, we should definitely note that the paper acknowledges a limitation here. This framework is currently descriptive, rather than derived from those elusive first principles.
That is a very important distinction to make. Chen's paper beautifully describes how the constants are organized and selected. It gives us the architectural blueprint. But it doesn't yet explain why the universe chose the golden ratio and the number 3 as its foundational generators to begin with.
Right. We still don't know who set the rules for the two tape measures.
We don't. But even as a purely descriptive tool, the explanatory power is just incredible. It completely reframes our relationship with reality.
It really does. Let's take a step back and just look at the journey we've been on. We started this deep dive with the profound mystery of physical constants, the frustration of these seemingly random hyperspecific numbers, like the speed of light or gravity, that strictly govern our lives.
And we introduced the mathematical phi spectrum and the physical ternary spectrum. We looked at how Chen measured the mismatch between them using the delta discrepancy function.
And we discovered that the fundamental constants of our universe, the very building blocks of mass, energy, and space-time, live in the narrow spaces where those two mathematical patterns perfectly align.
It replaces a universe of random dials with a universe of deep architectural order.
So the next time you hear about a fundamental rule of the universe, whether it's gravity keeping your feet firmly planted on the floor or the speed of light limiting how far our telescopes can see into the cosmos, try to picture it differently. It isn't just a random decree handed down from nowhere. It's a harmonious, perfect overlap between two grand, infinite patterns echoing across the universe.
And the paper actually concludes by acknowledging that this is really just the beginning. The author mentions future work refining the spectral alignments and running deeper statistical analyses.
And he also mentioned something that completely blew my mind. He suggests exploring alternative recursive generators.
Which opens up an entirely new frontier of questions about reality.
And that is what I want to leave you with today. A thought to chew on as you go about your day. Think about those two window screens creating a moire pattern. We know that the constants we experience, like the speed of light and the mass of the electron, are just the emergent intersections of the phi spectrum and the base 3 spectrum.
Right.
But what if you swap out the screens? What other undiscovered constants might exist if we find different recursive generators? What happens if an equation based on pi intersects with an equation based on the number 7?
Oh, the possibilities.
Are there entire other suites of physical laws, perhaps governing dark matter or dark energy, just hiding in the shadows of other mathematical alignments?
Mm.
Are the laws of physics we know just the visible peaks of a much deeper, hidden, hierarchical structure of intersecting patterns?
It suggests the thrilling possibility of physics far beyond what our current instruments can measure, simply waiting for us to find the right alignment.
It certainly makes you look up at the night sky a little differently. Thank you so much for exploring this fascinating framework with us. Keep questioning the world around you. Keep looking for those hidden patterns. And remember, the universe might not be playing a random cosmic lottery after all. It might just be making sure the tape measures line up.